All right, strap in, everyone. We're going deep on some CCSP exam prep today.
Yeah, really dive it in.
We know this certification's no joke, so we've gone through all those massive study guides, pulled out the stuff you absolutely have to know,
Exactly. Think of this as your CCSP cheat sheet.
with some fun facts thrown in.
Right, of course, gotta have some fun. But look, we're not just about memorizing terms here. It's gotta be more than that.
Right. Gotta understand why it all matters.
Exactly. That's what'll make you stand out on the exam.
And when you're actually doing cloud security work.
Couldn't have said it better myself.
So, first things first, a little cloud infrastructure review. It's the foundation for all things cloud, wouldn't you say? But here's a random thought. Did you know data centers used to be so cold you practically needed a winter coat just to walk in?
It's true. The old standards were way different.
Huh, interesting.
But before we get into why things have changed, let's make sure we're on the same page about the core parts of cloud infrastructure.
Sounds good to me.
You got your compute resources, virtual servers, serverless computing, containers. They're doing all the hard work.
Right, the workhorses of the cloud.
And then there's storage. Got your block storage, your object storage, each with its own purpose. And of course, the network. Can't forget the network. It's the backbone of it all.
Got it. So virtual servers, those are like splitting up one physical server into a bunch of little ones.
Yeah.
Right? Each one acting like its own separate machine.
That's it. That's the beauty of virtualization. It lets cloud providers divide those big, powerful servers and offer little slices to a bunch of different customers.
Ah, so that's how they make it so flexible and scalable. Like, I only need this much computing power, not a whole server.
Exactly. It's a big reason why cloud computing's taken off the way it has.
Makes sense. Now, what about serverless computing and containers? Those seem to be all the buzz these days.
Oh yeah, they're definitely hot topics. They take that abstraction from the hardware even further. With serverless, developers don't even think about servers anymore.
They just write the code and poof, it works.
Pretty much. The cloud provider handles all the infrastructure stuff behind the scenes and containers. They package up applications and all the things they need to run.
Making them really portable.
Super portable and easy to move around between different systems.
So it's all about making life easier for developers. Let them focus on the cool stuff, building apps, without getting bogged down in the nitty-gritty of infrastructure.
You got it.
Okay, that makes sense. What about storage? I know there's block storage, which is kind of like your hard drive, and then there's object storage, which is more like, I don't know, storing stuff in the cloud, I guess.
You're on the right track. Block storage is about giving you raw storage space. You can divide it up, format it, whatever you need. It's great for things that need speed and responsiveness.
Like databases.
Exactly, databases.
Right.
Now, object storage, that's designed for those huge amounts of data that isn't as structured.
Things like images and videos.
Exactly. And backups. It's more about being able to scale up easily than being super fast.
So block storage for speed demons, object storage for data hoarders. Got it. Now, networking, I know it connects all these different cloud pieces, but what makes it special for security in the cloud?
One of the key things you got to understand is virtualization and segmentation in these networks. Just like in a regular network, you want to control the flow of data, right? Make sure nothing sneaky is going on.
Right, prevent any unauthorized access.
But in the cloud, you can get super granular with it. You can create virtual networks, little subnets, security groups, all to isolate your different workloads and applications.
So it's like creating custom traffic lanes and checkpoints within the cloud, making sure data stays in its lane.
Precisely.
Now, I remember reading something about a management plane in cloud environments. What's that all about?
Ah, the management plane. Think of it as a separate, restricted network that the cloud providers use to manage everything.
Oh, so it's how they control all the cloud infrastructure.
Exactly. Provisioning resources, keeping an eye on performance, enforcing those security policies. It's all done through the management plane. And they keep it locked down tight, only authorized personnel allowed.
Makes sense. You don't want just anyone messing with the controls. It's like a super secret control room for the cloud, huh?
You could say that.
Okay, so we've talked about the virtual side of things, compute, storage, networking. But this all runs on physical hardware, right? Those huge data centers we hear about.
Absolutely. And those data centers, they're the bedrock of cloud security, both literally and figuratively. They house all the servers, the storage, the network equipment.
Right, all the physical stuff that makes the cloud work.
And the CCSP exam really wants you to understand how to keep those facilities secure.
Makes sense. Because if someone actually gets into a data center, all those virtual security measures might not matter much anymore.
Exact.
But building a data center, that sounds like a massive project. Do cloud providers always build their own?
Not always. They have a few options. They can build their own from scratch, buy an existing one, or lease space in a co-location facility. Each choice has its pluses and minuses when it comes to cost, control, and how quickly they can get it up and running.
So it's like choosing between building your dream home, buying a move-in ready house, or renting an apartment. Lots of trade-offs to consider.
That's a good analogy.
But no matter how they do it, redundancy seems super important. What does that look like in a data center?
Redundancy, that's all about having backups upon backups, making sure the data center can keep humming even if something goes wrong. Think multiple power sources, backup network connections, extra cooling systems.
Even spare hardware.
You got it. It's like
Right.
having spare tires, a
Yeah.
backup generator, multiple escape routes, all to keep things running smoothly.
So if one system fails, another one's ready to kick in. That makes sense. You can't have a single point of failure in place like that.
Exactly.
What about security inside the data center itself? How do they make sure different customers' data stays separated and protected?
That's where tenant partitioning comes in. It's all about creating boundaries between different customers' resources. Think of it like virtual walls within the data center, preventing anyone from snooping around where they shouldn't be.
So even though multiple customers might be sharing the same physical space, their data is logically isolated. Like having separate apartments in a building, right? You can't just waltz into your neighbor's unit.
Exactly.
Now, speaking of those data center buildings,
Mm-hmm.
how do we know how secure and reliable they are? Is there some kind of rating system?
There is. The Uptime Institute has a tier system that's pretty well known. They classify data centers based on how much redundancy they have and how good they are at handling failures.
Okay, so like a grading system for data centers.
You could say that. They go from tier 1, which is the most basic.
Up to tier 4.
You got it. Tier 4 is the top dog, the most resilient, and the one with the most uptime.
So tier 4 is like the Fort Knox of data centers, built to withstand just about anything. But I bet those are super expensive to build and maintain.
You're not wrong about that.
So what's the main difference between these tiers?
The big thing is how much downtime they can handle. Tier 1 can tolerate a bit more downtime, while Tier 4 is designed to be up and running almost all the time.
So choosing the right tier is about finding the right balance between uptime and cost. You wouldn't need a tier 4 data center for a simple website, but you might need that level of resilience for something like critical financial systems.
Exactly. And you got to know these tiers for the CCSP exam. They might ask you about the uptime requirements for each tier or give you a scenario and ask you to choose the most appropriate tier.
So it's not just about memorizing the tiers, it's about knowing how they're used in real-life situations. That's really helpful. Now let's move beyond the data center building itself and talk about security for the whole site.
Good point. It's not just about protecting the building itself, it's also about securing the area around it. Any other facilities that are part of it, like media storage or evidence rooms. And don't forget about those wiring closets, they're often overlooked.
Wiring closets, really? Why are those a security concern?
They might seem insignificant, but they often house important network equipment and cabling.
So if someone got into a wiring closet, they could mess with the network.
Exactly. They could tap into sensitive connections, disrupt communications, even plant malicious devices.
It's crazy how even the little things can have a big impact on security. So how do organizations find and fix these kinds of vulnerabilities?
Regular physical security assessments are key. They thoroughly examine the site, find any weak spots, and recommend what to do about them, like a security checkup for the physical environment.
So it's not just a one-time thing. It's about constantly checking and improving security to stay ahead of the bad guys.
You got it.
Okay, let's talk about what keeps those data centers running smoothly. Environmental controls.
Yes, the climate control. We got to talk about temperature and humidity.
Oh,
Those servers are picky. They need just the right conditions to work properly.
interesting. I always imagined data centers being freezing cold. Are they not anymore?
That was the old way of thinking. Modern data centers can handle a wider temperature range thanks to better cooling technologies and new industry standards. In fact, AirSRE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, they recommend a temperature range between 64.4 and 80.6 degrees Fahrenheit.
Okay, so no more park is required.
Yeah.
But why the change? What's the advantage of a warmer data center?
Energy efficiency. Cooling those massive data centers used to suck up a ton of electricity. But now, with modern designs and cooling techniques, they can run warmer without any problems.
So it's a win-win, saving energy and being kinder to the environment while still keeping those servers happy.
Exactly.
What about humidity? I know that can be a problem for electronics,
Definitely. Humidity has to be controlled carefully, too. Too much humidity, you get condensation.
which can damage equipment.
And static electricity, which is just as bad. It's all about finding that sweet spot.
So it's not just about blasting the AC. It's a delicate dance between temperature and humidity. What kind of systems do they use to manage all that?
Data centers use sophisticated HVAC systems and clever layouts, like the hot aisle, cold aisle setup, to make cooling as efficient as possible.
Okay, I've heard of hot aisle, cold aisle, but break it down for me. What's the idea behind it?
Picture rows of servers facing each other. The fronts of the servers, where they suck in the cool air, create the cold aisle. And the backs, where they blow out the hot air, that's the hot aisle.
Ah, I see. So by alternating them, you get better airflow and more targeted cooling.
Precisely.
That's pretty smart. They've really thought this through. But what about bigger threats like fire or flooding? I imagine those could be disastrous for a data center.
Oh, absolutely. And the CCSP exam definitely covers those topics. Fire protection is crucial, and you need to understand how fire suppression systems work in a data center. They're not your typical sprinkler system.
Right, because dumping water on all those electronics doesn't sound like a good idea.
Yeah.
What are some of the other ways they fight fires in a data center?
They often use special systems, like dry pipe systems that minimize water damage, or chemical suppressants that starve the fire of oxygen. And flooding can come from more than just sprinklers.
True, a burst pipe or a natural disaster could cause just as much damage. What do they do to prevent or deal with flooding?
Data centers use a bunch of methods: moisture sensors for early detection, carefully planned plumbing, and even backup pumps and drainage systems to get rid of water quickly if there's a flood.
So they've got backup plans for their backup plans, always thinking ahead.
That's the name of the game in data center security.
What about those less obvious threats, like electromagnetic interference? I know it can mess with electronics, but is it a real concern in a data center?
It can be. EMI can disrupt sensitive equipment and even leak data through electromagnetic waves. Think of it like eavesdropping on electronic signals.
Wow, sneaky. So do they build those Faraday cages to block it?
Faraday cages are pretty extreme and expensive. They're mostly used in high-security government facilities. But data center designers definitely consider EMI in their planning and shielding.
So they're thinking about all kinds of threats, from the obvious to the super subtle. It's like a constant battle to stay one step ahead of anyone who wants to disrupt or compromise these facilities.
You said it. And as we move on to discussing physical security controls, keep in mind that everything we've talked about so far, the infrastructure, the environmental stuff, the redundancy measures, it all contributes to protecting that sensitive data and those critical systems in the cloud. All right, so let's dive into those physical security controls. Think of them as layers of protection, each one designed to either deter someone, prevent them, or at least help you detect unauthorized access.
Okay, so it's not just about building an impenetrable fortress.
Right.
You also got to have eyes and ears everywhere. And what are we talking here? High-tech gadgets.
Yeah.
Or more traditional methods.
It's really a mix of both. You've got your technical controls like biometric scanners and super advanced alarm systems, but then you've also got administrative control.
Things like access policies and background checks.
Exactly, and visitor management procedures, all that stuff.
Right, because the tech is only one part of the equation. You need solid procedures and people who know what they're doing. Like, having the best security system in the world doesn't help if you leave the door unlocked, right?
That's a great way to put it. And then there are compensating controls. Those act as backup plans to address specific weaknesses.
Okay, so like extra layers of protection just in case. Can you give me an example?
Sure. Say you've got a fence around your data center, but there's a spot where someone could climb over. You might add a motion sensor there, or have a security patrol keep an eye on that area.
So it's about looking for weak points and shoring them up with extra protection. Makes sense. Now let's talk about those entry points to the data center. We're talking locks, keys, maybe even those fancy man traps they have in the movies.
Locks are definitely the first line of defense. And you need to know about different types for the CCSP exam. Traditional preset locks with keys, cipher locks that use combinations.
Biometric locks.
Yep, those two. Fingerprint scanners, things like that, and card-based locks.
So many options. How do organizations choose the right kind of lock?
Well, security is the top priority, obviously, but you also got to think about convenience, cost, and the level of risk you're trying to manage. Like a high-security data center might use multi-factor authentication.
So like a card reader and a fingerprint scanner together.
Exactly, just to add that extra layer of protection.
Makes sense. And I imagine keeping track of all those keys is a big deal. Losing a master key to a data center could be catastrophic.
Oh, absolutely. Proper key management is crucial. You got to know who has which keys, change the locks if a key is lost or stolen, and have strict rules about how keys are stored and handled.
It's all about reducing that risk of unauthorized access, because a lost key could give someone a free pass into the heart of the data center.
What about tailgating? I know I've accidentally followed someone through a secure door before. Is that a real concern or just a minor annoyance?
Tailgating can be a big deal, especially in high security places. That's where those man traps come in.
The double door systems. Exactly. They only let one person in at a time and often have extra security checks like weight sensors or a guard to stop unauthorized entry.
So it's a checkpoint within a checkpoint. Very clever. Now, let's talk about some of the more high-tech security measures. Motion sensors, video surveillance, maybe even laser beams. Is this spy movie stuff, or do they actually use this in data centers?
You might be surprised, but a lot of that spy movie tech is pretty standard in modern data centers. Motion sensors and alarms to detect intruders, video surveillance to keep an eye on things and record what's happening.
So like eyes everywhere, watching for any suspicious activity.
That's the idea. What about physical barriers? Fences, walls, even those big concrete bollards you see in front of buildings?
Those are still important. I thought that was kind of old school.
They're still important for basic perimeter security. They might not stop a sophisticated hacker, but they can deter casual intruders and slow down determined attackers. That gives security personnel time to react.
Right, it's about adding layers, making it as tough as possible for anyone to get in. And lighting and signage probably play a role too, right?
Definitely. Well-lit areas are less appealing to criminals, and good signage can prevent accidental entry or unauthorized access. It's all about creating a clear and secure environment.
So even those seemingly simple things contribute to the overall security picture. What about industrial camouflage? I've heard of data centers being designed to blend in with their surroundings. Is that a real thing?
It is. Lots of data centers are designed to be as inconspicuous as possible. They might look like regular office buildings or warehouses with no obvious signs of what's inside.
So it's like a secret data layer hidden in plain sight.
You could say that.
But you can't completely isolate a data center, right? What about visitors? How do you manage them securely?
Visitor management is a big part of physical security. You got to have clear procedures for authorizing visitors, keeping track of where they go, and making sure they follow the rules. You need to know who they are, what they're there for, and who's responsible for them while they're on site.
All right, you don't want just anyone wandering around a data center. What are some common ways to manage visitors?
Typical stuff includes having visitors sign in and out, giving them temporary badges, escorting them to their destination, and restricting access to certain areas.
So it's about striking that balance between accessibility and security, making sure legitimate visitors can do what they need to do while still maintaining a secure environment. Now, what about all those old hard drives and storage devices that data centers accumulate? Just deleting files doesn't seem secure enough. What if someone could recover that sensitive information?
That's where data and media sanitization comes in. Deleting a file doesn't actually remove the data, it just removes the pointer to the data.
So the data's still there on the drive?
Yep, it's still there, and it can be recovered at the right tools. Data sanitization involves overwriting the data multiple times with random patterns.
So you're basically digitally shredding the information.
That's a good way to think about it.
So just hitting delete isn't enough. You got to go the extra mile and make sure that data's really gone. But what about data stored in the cloud? You don't have physical access to those drives. How do you sanitize data in the cloud?
That's a great question. In cloud environments, it's usually the cloud provider's responsibility to sanitize data. They either use secure erasure methods to wipe the data from their systems, or they use techniques like cryptographic erasure.
Cryptographic erasure, what's that?
It involves destroying the encryption keys that protect the data. So even if someone got their hands on the storage devices, they wouldn't be able to access the data without the keys.
I see. Like a treasure chest with a lost key.
Exactly. Now let's switch gears and talk about packet capture, which is a really powerful tool that cybersecurity pros use to analyze network traffic. It basically lets you see what's happening on the wire.
Okay, packet capture. That sounds a little like digital eavesdropping. Is that ethical?
It depends on the context. Packet capture is used for legitimate things like troubleshooting network problems, analyzing security threats, and investigations. But it can also be used for bad stuff, so it's important to have rules and ethical guidelines in place.
So a powerful tool that can be used for good or evil. What are some of the tools used for packet capture?
Two popular ones are Wireshark and TCP dump. Wireshark is free and has a nice graphical interface, so it's easy to use.
And TCP dump.
TCP dump is a command line tool, more suited for scripting and automation.
Got it. Wireshark for those who like visuals, TCP dump for the command line folks. Can you give me an example of how packet capture might be used in the real world?
Imagine you're looking into a security breach where someone may have hacked into a server. By capturing and analyzing the network traffic to and from that server, you can see what data was sent, maybe figure out what the attacker did, their IP address, or what files they stole.
So it's like a digital detective piecing together clues from the network traffic.
Exactly. And packet capture isn't just for reacting to security incidents. It can also be used proactively. Things like performance monitoring, troubleshooting, and even detecting strange activity that might point to an attack.
So it's a versatile tool that can be used on both offense and defense. But what about TC Preplay? You mentioned it earlier. What's that all about?
TC Preplay is another tool built on the same foundation as Wireshark and TCP dump, but it's used to edit and replay captured network traffic.
So you can basically rewind and replay what happened on the network.
You got it. It's helpful for testing security controls, simulating attacks, or even troubleshooting tricky network problems.
But I can also see how that could be dangerous if it fell into the wrong hands.
Absolutely. TC Preplay is a powerful tool and should only be used by authorized people for legitimate reasons. Think about an attacker using it to replay stolen login credentials or change sensitive data that's being sent over the network. That's why strong security controls around access to these tools is essential.
It's like giving someone the power to rewrite history, but in the digital world. We've covered so much today, from the physical security of those data centers to the details of packet capture. Cloud security is a pretty complex field.
It definitely is. And as you get ready for the CCSP exam, remember it's not just about memorizing facts. It's about understanding the principles, the concepts, the best practices that make up cloud security. Think critically, connect the dots, and consider what it all means in the real world.
That's great advice. So what's next on our CCSP deep dive journey? So we've explored those physical data centers, the servers, the cooling systems, all of that. But what about the virtual side of cloud security? How do you keep data safe in this intangible world?
That's where cloud security architecture comes in. It's all about designing and implementing security controls that protect the data, applications, and the entire infrastructure in the cloud.
Okay, so it's like baking security into the very foundation of the cloud environment.
Exactly. And we're talking everything from network security and access control to data encryption and compliance requirements, the whole 9 yards.
Right, because those rules and regulations are a big deal in the cloud. I know the CCSP exam really focuses on real-world applications, so what are some key concepts someone studying for this exam should really zero in on?
Well, one of the most fundamental concepts is the shared responsibility model. It outlines how security responsibilities are divided between the cloud provider and the customer.
So it's not just one entity taking care of everything, it's a shared effort.
Precisely. And here's the thing. Those responsibilities shift depending on the service model. Infrastructure as a service, IA, platform as a service, PA, or software as a service, SaaS.
So it's not a one-size-fits-all approach. The lines get a little blurry, huh?
You could say that. It wouldn't make sense for someone using a SaaS email service to worry about the physical security of the servers in a data center, would it?
Right. That wouldn't make sense at all. So how do those responsibilities break down?
Well, in SaaSes, the provider handles pretty much everything. The physical infrastructure, the application security, the whole shebang. But as you move down the stack to PaaS and IaaS, the customer takes on more responsibility.
Okay, so the more control you have, the more you're responsible for.
You got it. In PaaS, you're in charge of securing your applications and data, while the provider manages the underlying platform. And with IaaS, you're essentially renting the infrastructure building blocks and need to handle a lot of the security yourself.
So it's like a sliding scale of responsibility. Makes sense. What about specific security controls that come into play in a cloud environment?
Well, network security is always a top priority.
Right, keeping those bad guys out.
Exactly. We're talking firewalls, intrusion detection and prevention systems, virtual private networks, and secure network segmentation. All those tools and techniques we use to control traffic and keep unauthorized users out.
So you're building a virtual fortress around those cloud resources.
That's a great way to put it. And with so many users and applications interacting in the cloud, identity and access management is crucial as well.
Right. Making sure only the right people have access to the right resources.
Exactly. Strong passwords, multi-factor authentication, role-based access control, even things like federated identity management, which lets users access multiple cloud services with one set of credentials.
Wow, that's a lot. But I can see how it simplifies things in a complex cloud environment. Now, data encryption, that has to be a major focus, right? Especially with all that sensitive information floating around in the cloud.
Absolutely. Data encryption is fundamental to cloud security. We need to protect sensitive data both in transit over the network and when it's stored. This involves using encryption algorithms, key management systems, and secure communication protocols like HTTPS.
So even if someone manages to break through all those other defenses and get to the data, it's useless without the key.
Exactly, like putting that data in a vault that only authorized users can unlock. But then you've got all those rules and regulations. Compliance is a huge deal in the cloud world. How does that fit into the security architecture?
Yeah, you can't just ignore those regulations.
You're absolutely right. Cloud environments often have to meet specific security standards, regulations, and industry best practices. IPA for healthcare data, PCI DSS for payment card data, GDPR for personal data protection, the list goes on.
So you have to make sure those technical controls actually align with all the legal and regulatory requirements. It adds another layer of complexity.
It does. And the CCSP exam will test your knowledge of these compliance requirements. You'll need to know how they impact cloud security architecture and how to design solutions that meet those standards.
So it's a multifaceted puzzle. You've got technical controls, IAM strategies, data encryption, and then you have to layer on all those compliance frameworks and regulations. It sounds pretty demanding.
It can be, but remember, the CCSP exam is about testing your understanding of these concepts and how you'd apply them in real-world scenarios. Think like a cloud security architect. Consider the threats, assess the risks, and design solutions that are both secure and compliant.
Finding that sweet spot where security, functionality, and compliance all come together, but it's not a set it and forget it deal, right?
Definitely not. Ongoing security monitoring, incident response planning, and continuous improvement are all critical parts of a strong cloud security architecture. The threat landscape is always changing, so you have to be ready to adapt and evolve your security approach along with it.
So it's a journey, not a destination. You have to stay vigilant, keep learning, and be proactive. Well, I've got to say, this deep dive has been incredibly enlightening. We've covered so much ground from the physical data centers to the intricacies of cloud security architecture.
We have. And while we've only scratched the surface of this vast and ever-changing field, I hope this deep dive has given you a strong foundation and some valuable insights to help you on your CCSP journey. Remember, this is just the starting point. Keep studying, keep learning, and don't be afraid to ask questions and explore different perspectives. And most importantly, apply what you're learning to real-world situations. That's what will truly prepare you for the CCSP exam and set you up for success in your cloud security career.
Great advice. That's it for our deep dive today, folks. Good luck on your CCSP journey.